a way to get a deeper understanding and know whether or not students understand what 4/3 is or what an improper fraction is.
I would start by having compared,
Let's listen.
compare the two, because you've got a proper fraction above and an improper below. So, you know, first of all, how do you do these two exercises? And then do a comparison of what's different, what do you notice, and why? And then take it a step further and ask, can they create two new situations, two new fractions that would fall into the pattern of the
Okay, so you've got a couple parts of that. Let's deconstruct that. Let's go back to the comparison one. So they've maybe done this basic task, and now you're asking to compare two fractions and understand how they're alike or different.
Exactly.
So what would that part of the task get you to? Comparing, so that would get you to it too, because you have to have some kind of a representation for the first one, the second one. It's got to be in some form that you can make a comparison, so you're going to know as a teacher, do they really understand, and can they translate it to that point and compare and say one to more or less or something. Now, what's your second part?
Now, they would need to create a new fraction in sort of each category. Like there's a pattern forming, they should see the difference. So create one that would follow the proper fraction, a different one, and an improper one, and then sort of now say, okay, what are you noticing? Make a generalization that if the numerator is larger, this is happening, but sort of have them go out and create some, follow the pattern.
And so what DOK level do you think that is and why? That second part. If they're actually generalizing, creating a rule. Well, they're sort of creating a rule for why this one is a proper fraction and this is an improper. So kind of generalizing, wanting to generalize, I think. And explain why that rule would fit for any fraction that falls in this category or that category. So what would that be? Okay, let's vote. Oh no, that's not a good way to say it. So how many people think it's a 2, and then we'll hear your rationales for why it might be a 2.
For the second part you're talking about?
Yeah, for the second part. You think it's a 2?
No, I think it's...
Okay, then you can't talk. Only people think it's a 2 right now. Let's hear from 2 people.
I thought it was a 2 because it talks about create to generate a conjecture or hypothesis, and this is making a generalization based on evidence.
Okay. Okay, that's a pretty good rationale. So how far do you want those kids to go? Do you want them to have a hypothesis that they think this is the same, but they don't have to actually test out the hypothesis?
What do you mean by that?
Well, testing out the hypothesis means you try a lot of examples and they all seem to fit, so you can then you're confirming.
Then it's different.
Then you're confirming it with evidence. That's why I'm asking.
Well, that's why I was saying they should go forward and do new, they're not just staying with the 1/8 and the 4/3. They need to come up with other examples that will follow the pattern.
Okay, so
Their generalization.
So you've made a good point. If they're just coming up with what they think is a good rule,
With evidence.
with some evidence, but maybe they haven't really tested out and say it's always going to work because I've tried it in X number of cases and here's my supporting evidence, what would that push it to? A 3. Do you see how that's a little bit different? It's like making a prediction or making a hypothesis based in logic is a 2, but testing it out and then supporting that you either you proved it to be true or you proved it not to be true, and this is the data that supports.
Well, and to
your
be honest, in
conclusions.
math, what you just said is like, you have to be careful as you go in higher math because you don't prove it by just doing 6 examples. In math, really, a proof is going to be that it works for everybody in general context.
Right.
So, you know, it is sort of a danger sometimes, and the word proof I'm very careful about.
Okay, but I'm saying prove it with your evidence or justify it with your evidence. So in this case, you're asking them to really define a proper fraction and an improper fraction, come up with a rule for it, and show some other examples of it. But if you wanted to know, does that rule always work,
Yeah,
then you have to do more. And I will tell you, the hardest decisions are always a really good, juicy level 2. And how is it different from a really good level 3? Usually a level 3 has to go deeper. So we've heard an argument for 2 on that example. Does anybody want to argue for it's a 3? Does it feel more like it's a 2? You're kind of coming up with a rule, you're finding some examples or non-examples, this one fits, this one doesn't fit, but maybe we haven't gone so far as to say it's always going to work. And I've gone deeper there. And then the question you ask yourself as a teacher, is this one where you need to go any further? Probably not on this one. Where you want to go deeper to 3s is not going to be for every single thing. If kids can give you examples and non-examples, that's a pretty solid conceptual understanding. They can apply that in a problem-solving situation where they're bringing that information, and I can show you one this afternoon where they're actually applying that thinking in a problem-solving task. Not your task, but their understanding of an improper fraction. That's what you really want them to understand, is how does that work in the real world if you're solving a problem. Okay, any insights, new insights, epiphanies? Yes.
Well, epiphany.
Sometimes I have prizes for that. I don't have any today, but sometimes I do, but you can, let's hear your epiphany.
Well, as we're trying to unwrap and get our heads around the new standards, the idea of choosing those priority standards, you want to get the bang for your buck. So you want to identify what your intent is so that when you're choosing the 3 and 4, that you're really hitting a lot of those basic skills standards along the way. So you really have to do a lot of studying to figure out what your intent is.
It's like, where do you need to go deeply? You don't need to go deeply in everything. But when you do, be selective about that, and we're going to spend a good part of the rest of the day talking about, so where are those performance tasks that you're going to say, this is going to show me they have a lot of the pieces and they know how to put it together and they can articulate their thinking. And you don't have to do that with many of the concepts, but it's when you want the concepts to go beyond just application. You want them to go into a real-world problem that could have a variety of different solutions or ways to solve it. That's where you sort of uncover their mathematical thinking. And you often don't get that, first of all, if you don't ask for them to show their thinking. So that was one reason, sometimes that happens. We were doing some work somewhere, and it was a very clever street vendor. First he saw a couple of women walking down the street. He says, okay, easy target. He has these parrots. He's like, oh, hey, look, you want to put your arm out? Then he's like putting parrots on your head and everything. Now you got an exchange of those parrots, and you're like, oh, okay, this is really cool. You're taking pictures, and then he ends by saying, could you make a donation to feed the parrots? He's like, oh, yes, I guess we have to. Okay, so kind of going back to this, we've looked at the bookmark, we've looked at T-bear, we've looked at the fractions, just to start to get you thinking about when you look at a task, what's the question that's being asked and how far is it going to take kids? Because just how we ask the questions is going to get them there. Later on we'll look at some sample rubrics, but not right now. But as we look at any task, what's the purpose? What's the implied rigor? And you'll get better and better at it as you use it. Where would this be used? Some of those are fine, and maybe okay, one, it's the beginning of a unit, you're trying to find out what they know to get started. What standards is it aligning with? And then the last one is a really important one. Will the student responses tell you what to do next? So discourse in the classroom, are you probing? It's often the second question a teacher asks, not the first one, that really gets a little bit deeper. So the first one is kind of like, I'm going to, hit the ball out and see who catches it. But now I want to know how you caught it, why you caught it, what you're thinking about, how's that ball feel now that you have it in your hand. So it's the second question, so is that going to tell me enough? And actually, what I like about this resource, this doing homework together, it does show you some student responses, and you look at that, and it does reveal where the kids are in their thinking. The student who says Sienna because her answer had an 8 in it, Karin was the only one with an 8 in it, so hers must be right. It's like, okay, we have a little work to do there. But if you don't get kids actually expressing enough, either verbally or on paper, that you can do some analysis, then it's really a guess. Kind of guessing that they're with you or not with you. So, oops. Come on. Oh, you know, you really, oh, that's too bad. I can't really see that. So let me tell you what it is. So, maybe it's just, I don't know if it's too light in here, because I can see it in mine. But this is an example. These are 3 tasks. You really can't see it. But the first one was, how many wheels do 29 tricycles have? So here's what the student does. This goes back to, can they solve it in different ways? So this kid has drawn 29 tricycles, drawn 3 wheels on every tricycle. We all have a kid like that, right? And counted them. Did the student get the right number? If they can count to 84 or whatever it is, yeah. Okay. So that's a student still using an additive strategy from 1st and 2nd grade, and they haven't transitioned in 3rd or 4th grade to know that there are patterns in numbers. So the second one actually has rows of smiley faces and says, write an equation to match this picture. And what you would see 1, 2, 3, 4, 5, you'd see 6 rows of 3 smiley faces, and the kid has written 3, 6, 9, 12, so there's like a skip counting going on across the top. Then you see the kid has written over here 3, 6, 9, so he's writing the pattern, or she is writing the pattern, and then the student writes 3 times 6 is 18. So that's kind of a transitional strategy. A little bit of skip counting, so not quite at multiplication, kind of like doing that adding thing to get at the equation. And then the third one says, Farmer Brown has donated 7 dozen eggs to the senior center. How many eggs did he donate? And this student has 2 times 7 is 14, 10 times 7 is 70, and gets the answer of 84. So what has this student done? What has this student shown you? They've taken the 12, and you know what it does, it does a 10 into it. They're using what property? Distributed property. So I can look at my student work if I get them to put enough on the paper. And if I only was asking the question, they all might have gotten the right answer, but they might not be where I want them all to be. So when you're thinking about, if you ask them, how did you solve this? If you don't have enough, showing your work sometimes is enough, but sometimes as the tasks get a little bit more complex, you need to know what the thinking was, why do they do it in that way? And so that's what's going to move it to, what's your reasoning, not what steps do you take, but so I could even ask a student, well, why did you have 10 and 2? Why did you do that? I could just interview those kids, say, tell me why you did that. That would confirm what I think they know, but I would be assured that that really is why they did it. So let's take a break, take a stretch break, 15 minutes, and have a few minutes to process what we've done up to this point. So I want you to focus on the first and the third question right here. At your tables, go back and look at your first definitions of rigor. Just talk at your tables, how has that changed? And just up to this point, how can you apply what we've been talking about this morning in your own work back in your schools or in your different roles? So I'm going to give you some time to just talk at your tables, about 10 minutes, to just have a short discussion, and then we'll have a larger group discussion. Thank you. So let's hear some of your thoughts right now at this point of how you think you can apply this in your work back in your schools. What are some ideas that already are starting to emerge?
I think I have to go from a math standpoint first. I can see going the 1, 2, 3, 4 in LA and getting those multiple resources multiple times, But I think in math, it's getting us to the 3 more often, explaining your reasoning, different approaches, throwing out a problem, letting kids do it different ways, explaining why they did it, that type of thing. But that 4 is tough in math. It's going to come probably touching science. and time allows for that to happen.
I often get follow-up emails after I do this workshop and it's around that question, like how often, or what are some rules of thumb? And because the way the math Common Core standards are written, they are not really written to go to 4. So my rule of thumb is in every unit of study, you ought to get to 3. You ought to be doing problem solving that is not word problems, but it's solving and using reasoning, and they're non-routine. And so when I work with schools, we usually say for every unit, think about where you want them to end up. What do you want them to be able to do with the discrete skills and concepts you're teaching them? How do you want them to apply them out of 2? But how could they actually demonstrate their understanding, transfer some of that understanding in a problem-solving situation? And if we keep stopping short, well, I'll do it the next unit, I'll do it the next unit, and you do it a couple of times, your kids can't solve problems. And I know last year we worked with New York City public schools, and we did a 3-day institute in August, and teachers were like, our kids can't do that stuff. In October, they were coming back and saying, look what my kids can do. I think part of it is we stop short because maybe we're like, well, it's going to take some extra time, and it does take time. But it's amazing when you hear a kindergarten student saying, I think I'll use a diagram, or I think I'll use a tally chart, and this is the way I solve my problem. And or a first or second grade saying, I know I have to have a key, so if I'm having a diagram, I'm not drawing a picture. A picture is different from a diagram or representation. They understand that if they can have one apple representing all of the apples. So when they start to understand at that level, because you've been asking them to do it on an ongoing basis, that's very powerful. So the rule of thumb, I would just say with math is get to DOK 3 several times in a unit, so they're having the experience of hearing people think out loud, they're able to challenge different ways to do it, or find alternative solutions if this doesn't work, because that's what teaches perseverance. In ELA, because there are so many standards that at every grade level that start to say multiple texts, they say it in a variety of ways, like you will research a topic, so that's what applies. You're not going to just research it reading one text, you're going to read more than one, or you're going to compare texts by the same author, so that applies. Or you're going to compare characters in different stories, or you're going to compare a play version to a text version of something, or a movie version. So you're probably going to get to DOK 4 more often, but I would say in classrooms, K2, a lot of that's going to be through shared book experiences. It can be through discussion that you talk about books, multiple books, come back, revisit how are they alike and different. Maybe they're not actually putting things on paper. In grades 3 and on up, it can, DOK 3 ought to be happening all the time in discussions about text. You should always be pushing a little further. So whose point of view is this? Why do you think that? Where is it in the text? Asking text-based questions. Something, this is another thing related to that, is the idea of prediction. It's not in any of the materials I'm going to give you now because it's in a different workshop, but when we think about text-based questions, what's going to send you into the text to answer the question? When we ask kids to make predictions, typically we say, did this ever happen to you? Do you know an experience like this? So that's an episodic prediction. That's episodes in my own life. And we all know, we've been in classrooms, that I gotta hear your story, your story, and I'm not being fair, but I hear everybody's story. So the other kind of prediction is a semantic prediction. It's what do you know about how stories are put together? So what kind of a story do you think this is going to be, and why? What kind of a book do you think this is? I mean, I've been in kindergarten classrooms where the teacher holds up a book and says, do you think this is about real butterflies or fairy tale butterflies? How do you know? Well, there's photographs. You know, like, we're already starting to differentiate the kinds of text. So what we try to do is we try to build like semantic maps in kids' minds. In mathematics, have you had a problem like this before? What did you learn from that problem that's going to help you in this problem? So making predictions is a good thing when we're trying to build a semantic map, an organizational structure. We know that the difference between a novice performer and an expert performer is not about their innate ability. It's about their ability to create schemas, mental schemas, so the new information fits somewhere. So I think it's a mystery because I've read other books by this author and they were mysteries. Or I think this is a mystery because already we've read 2 pages and I think there's some clues here, there's some foreshadowing. It's going to tell me that this is a mystery story. So now my purposeful reading is to check my prediction, and I can only check if I go into the text. My only way to know if my strategy is going to work is to try it out, and then I'll be able to say, yeah, that does connect with, it is a similar problem that I've seen. So that's what we're kind of going for in sort of moving kids along. But that's why I say it's not like one DOK is better than another, and I think it is slightly different for the content areas. So it's good to kind of keep that in mind. I think it would be good to have project types of activities that might happen in the later part of the year that would be mathematics, that would integrate mathematics into real world kinds of activities, projects that kids could apply their mathematics in the real world and bring in science or social studies concepts with that. They could be conducting surveys about things, those kinds of things. Other comments about how you can see this in your own work?
Well, I used to do a thing called a think aloud in my class, and I kind of model that, what are you thinking? And we do it a lot, and I'll do it, and I'll say, well, what did I just do? And they're like, oh, you did a think aloud.
Mm-hmm.
So every day we do a 5-minute check math question in the morning, and students go up, and I'll say, well, they didn't want to do it a different way. And they'll have to go up and explain it to the class and how they did it and explain their thinking. So I use the word think aloud and I
Right,
do
that's
it.
a good phrase. What grades?
Second grade.
Second grade, okay, that's a good phrase to use. Because revealing your thinking is very powerful. I can remember a kid in school being like, how did they get that? Like, things would just keep moving on. And be like, how did they know that was a theme? Teacher said it was right, they moved on. I'm like, where is that information? So revealing your thinking and modeling it for kids, and then it really does tell kids that that's part of what you're supposed to be doing. You're not supposed to give an answer. I was sharing that my understanding of mathematics changed when I hit 9th grade, and my algebra teacher said, every assignment I'm going to give you the answers. Your homework is to try all these problems and come in and say which ones you couldn't get. Those are the ones we're going to focus on. It's like, whoa, that was a game changer for me. It's not about the answers, it's about getting the answers, knowing how to get the answers. So we spent time each day talking about the 2 or 3 problems that everybody struggled with. And it was okay that, like, that was the focus. So she was really doing a lot of formative assessment and kind of shifting to that thinking piece. It shifted that it wasn't about the answer. It was about how to get there that was important. Other thoughts, just up to this point? I try to create the PowerPoints and presentations, so you could probably do this. Do you think you could do what I just did with you so far? Those pretty much. Well, you might not have the level of how I sort of analyze the questions, but you back in your schools, I think you could have the same kind of conversations about how do we define what does it look like if we have some examples that sort of go along the continuum. We can start to say, well, now I see a new one. What is it most like? And sort of sort the kinds of things I'm doing. That's the whole idea. Is people usually their awareness is raised just up to this point of, okay, now when I look at a problem-solving task in math, I'm really saying, am I looking for reasoning, or am I just looking for the right answer? And am I satisfied and okay with that? And sometimes spending more time on the thinking aloud and less time on a lot of repetition is going to give you a lot more in the end, because you're really moving the kids conceptually. Okay, so we've had a chance to have a couple minutes to kind of solidify some of that learning, but you know what always comes next: practice. Okay, so we're going to do some practice. So when I was teaching in New Jersey, it was when there was a mandate in New Jersey to teach gifted education. And I was in a little K-8 school, and I was a 6th, 7th, 8th grade math and ELA teacher, because in those days I taught all the math, and then everybody taught ELA at home, so we did a little bit of both. And, you know, when they said, well, somebody's got to work with these kids, and I was always like, okay, I'll do it, and then how hard could it be, right? Well, that set me on a path to get a master's degree in gifted education. And that's when I really started to think more deeply about cognitive rigor. So kind of going way back to the early 80s. I really started thinking about it. I was a regular classroom teacher, so I was like doing this stuff with all kids in my class, even though it was my job to create a curriculum for a gifted and talented curriculum. I was saying, well, this is probably good for all kids, so I'll do my little research and development in my classes to do this stuff. And when we talked about differentiating instruction back then, Carol Tomlinson was doing this way back then in gifted ed, and Heidi Hayes Jacobs was doing it back then, and Jay McTighe was. So a lot of people who are you now hear who are doing curriculum work and this were all kind of based in this same idea that you can differentiate really in 3 ways. You can change the products, the final products that are produced, so kids can have choices maybe in how they show what they know. But the other 2 are the content, so you might vary the content, you might jigsaw things, you might give some kids easy stuff and other kids harder things to read. And the 3rd is process. And we were really talking about depth of knowledge back then, but we weren't calling it that. And the way you vary process is you might have different cognitive demands for the tasks. So I came up with this idea when I was learning about differentiation, and I thought, well, I have, I got all these groups going in math already. How much more can I do? But I came up with this idea of an assignment menu. So you're going to create one in a couple minutes. But the way I came up with it is I kind of came up with, now those 1, 2, 3s didn't really mean be okay when I started thinking about it. They meant it's getting more challenging. And so I would come into my class and I'd have problems on green cards, and they were 1s, and yellow cards were 2s, and red cards were 3s, or something like that. I had 3 color-coded cards. And kids were allowed to choose. Do you want to take the really hard task and wrestle with it? You only have to do 1. Do you want to have a 2 and maybe you have to have 2 cards? And if you pick the green cards, you got to do 5 of those. So some kids are like finding the interior angle of a triangle, doing it 5 times. It's like, but there were kids right away like, I'll take 5 of those green cards, Mrs. Hess. Okay, good, you got it. And then there were other kids like, let me try the yellows. But it was only like the really adventurous one. Be like, I'll wrestle with the orange ones. Well, they pretty early found that it was kind of more interesting to do the yellow and the red cards, the more challenging tasks. And if they did that, I knew that they could do anything on the green cards. So that's where I got the idea from. And then I started to create a menu. And this is an example of a menu for To Kill a Mockingbird. But the idea of a menu is take what you're going to teach. Take a topic. In this case, it's a book. But you could take fractions, my unit on fractions, my unit on place value. And then the idea is to create different assignments and say, what are the easiest ones? I'm going to put them on the bottom row. What's a step up from that? I'm going to put it on the next row. And so even though the 1, 2, 3s don't mean DOK, and here's the reason why, I have initial understanding of text. If you can really understand the text and summarize it, you're still only going to get to a 2. But creating a quiz or creating a graphic organizer, that's harder, that's more challenging than just making a timeline. Okay? So the 1s, 2s, and 3s, they could. I mean, I could have easily changed this and had 4 rows. That's lazy, because if I do that, then it doesn't all fit on the front page. I was thinking about, I want to be able to see the whole thing on the same page. So, but I could do that. I could make it 4 rows, 1, 2, 3, 4. But the stuff at the top, you'll see a combination of 3s and 4s and the other 2. So the idea is, I might create this assignment menu, and everybody doesn't have to do all the assignments, but you have to do a combination of assignments so it adds up to at least 1, 1, 1, 2, 1, 3, or it has to add up to 10 points. I mean, it's arbitrary, we make this up all the time, we know this as teachers. But what I found was, when I gave kids choice, they actually did more assignments than they had to do. They gravitated pretty quickly to the ones at the higher level, and it felt more satisfying. And because it was okay sometimes to work with other kids on those things, built-in scaffolding, they were able to do that. So you're going to create an assignment image. You're going to think about, it might be a unit you're working on now, or something you're going to do next. Or you could take a book, you could take a topic, it could be a math topic, it could be an ELA, a couple books, it could be anything at all. And your job is you get a blank template, you work with people at your table, you need to move to find somebody who's smarter than you to work with. When everybody stands up, I'm really going to get hurt. But your job is to just say, what would be some simple, less complex assignments? And you can put any heading you want. Now, I used initial understanding, analysis, and opinion. But don't even worry about even having different headings. If you just wanted to say, what are some simple, in math it could be skills, concepts, and problem solving. It could be something like that. I'm not worried so much about what your headings might be, but I want you to think about, just it's sort of like a brainstorm, but you're categorizing your brainstorm, and you're thinking about, well, if they could do this, if they could find the third interior angle of a triangle, then they could probably do something a little bit more complex here, and what would be a problem-solving task that I might put at the top? That's kind of what you're kind of building that idea of how might I, maybe in a unit of study, move down to something a little bit more complex. Questions?
Just before, because I just kind of want to read myself on how you created this menu. What would have been your objective, your learning objective for all these pieces? Because what I'm trying to figure out, like, did you have an objective for initial understanding?
Yes.
And then one for the analysis, and so each of those have one
Yes.
learning objective in your pieces.
I very clearly wanted to be sure that kids knew what the text was about.
Okay.
And so you could either do a timeline to get there, you could create a map, which is a little bit more complex than a timeline, or you could actually create some kind of a graphic, some way to really, like, I remember when we read, what was the one where they're on the island? I hadn't created a map of the island, I'm trying to remember. What where they have the conch shell?
Lord of the Flies.
Lord of the Flies, thank you. See, I'm not good at recall. But like Lord of the Flies, there were kids that like, these were like kids who could barely read. Just a timeline. There were some kids who were like, okay, just get the timeline. So this might have been during the first week, you've got one of those assignments, but as you start to share, there were kids that could only do that, but then they could understand the math, and then they could understand the other one above that. So that might have been, like you have to pick something from column 1 this week as we're reading and discussing. And now I'm going to move you to interpretation. So now I'm going from a main character to now persuasive essay or compare and contrast. I'm kind of moving that one up. And then in the end, I want you to do an overall response. So this is a little bit more creative, but now this is journal entries for characters. So I did have something in my head about where I was going by the end of the unit, but everybody didn't have to do the same assignment. But what made the classroom discourse rich was that because kids were doing different things, they could build their understanding from where they were. So, there might be students who pick one, and well, I could have done that, so the next time they're going to pick something maybe a little bit higher. And you'll even see the ors, so you could do this or that. So, like there's options within the options. It's like, it's a menu, that's why I call it a menu. So everybody doesn't have to do everything, but I'm pretty sure that at the end of this unit, kids will know what the text was about, they will have done some analysis and interpretation, and will have created some kind of a response. And even this one is at a DOK too, so even if they're landing right in the middle there, they're still doing something that's got some complexity to it. So yes, absolutely. So these 3 categories work pretty consistently. I could use that for a lot of different ELA stuff. For math, I tended to use skills, concepts, and problem solving. In science, it might be procedures and concepts and input or something like that.
Process.
So you're going to pick pick a topic or a text or an anything, and you're just gonna do a brainstorm. See if you can create a menu around think bigger than a lesson, like a series of lessons. You use that. You gotta have it. But it's 20 minutes. Okay, we're getting some really good questions, so I want to capture some of those before we forget. I know everybody hasn't filled in all the examples, but one question that came up here is for first grade teachers, how far can you really get with first graders? So let's just talk a little bit about that. So we were talking about they didn't have too much trouble saying, well, a student might, for initial understanding, for example, might be able to just draw a picture and then they can tell you about it. Okay, that's good. Or another one might be able to do something a bit more complex, maybe actually do some writing or acting out. And then when we got to the conceptual, so there are some kids that could put pictures of events in the story, they could start to sequence it. So that's like would be a DFK2 kind of thing. And so what we're talking about is, so how do you get them to find evidence in the text? So one of the things that the story is the big pumpkin. The big pumpkin. They're talking. So the story is the witch is going to take the pumpkin away, but it's so big she can't take it away or something. And then the other characters come in, and so it's like about cooperation, working together, so they get this big pumpkin. Did I sort of get it right? Somewhat. Yeah. So there might be some kids who can go back into the text and just find, where does it tell you something about the witch? Or can you find something in the story that shows you that the witch is kind or the witch is mean, and they might be just looking for illustrations. Other students might be able to find the part in the story where they're working together. Now we know when you read a story, you don't read it once, you read it multiple times. So the first read through might be getting at who's a character in the story. The second read through might be about sequencing events in the story. And we know that there's a ton of research that says we don't do enough oral processing at any grade level, and that's what builds language comprehension across all content areas. And so the more exposures, the close reading, what close reading looks like in kindergarten and first grade, our kindergarten teacher here, is the more times you read that story over and over again, because that's when you see things you didn't see the first time through, the second time through, the third time through. So the third time through, then you're sending them on a scavenger hunt, and maybe you're taking the text apart, and some kids you know that can probably do a little bit more complex, like where is that part where they're actually working together, they're solving the problem, or other ones you're finding, you know, where was somebody struggling with the big pumpkin, all by yourself. So you can vary the kinds of questions and send them into text to find the answers. It doesn't have to be that they're writing, it could be orally. Or I was saying they could take on roles of characters at a higher level, and you could be interviewing them. So a witch, you know, why were you doing that? What were you thinking? Why did you say that? So you really sort of, I mean, and you can do that, and they can role play, and like you do it 10 times. Everybody wants to be the witch, everyone wants to be the chipmunk or whatever else was in the story. It's okay. I mean, it can kind of be boring to you as a teacher to have to do it like so many times, but for them, it's like they're getting to talk about it. So kids who are language impaired for whatever reason, it's a second language, they're getting a chance to hear the think aloud several times. They're getting a chance to summarize orally because someday they're going to have to write a summary. So the more they learn to practice paraphrasing and summarizing, what does that mean? So don't be constrained by they might not be able to write, but they can certainly talk, act out, and manipulate materials. Does that help people maybe who are struggling with lower grade? And then another thing that came up was that we've been told that there's more focus now on shorter text and not longer text. So let me clarify what that really means. Common Core says you need to read complex text. And so some of the pushback has been to the Common Core writers in particular, well, what if all kids can't read complex text? And their answer is, well, then you don't have to read all long complex text. You can do shorter texts that are complex or excerpts from text. The message isn't stop reading novels, stop having literature circles where maybe different groups are reading different novels and they're sharing across those groups, what's the theme, what's the, the main character, what's the problem in the story. That should not be the message, the takeaway message. It's that if you want all kids to reach the level of understanding complex text, you might have to go with some shorter parts of complex text so they have that exposure to it. It might be that you read it out loud to them as opposed to them reading, because it always says across the Common Core standards with scaffolding. They don't define scaffolding. So what scaffolding mean? You work with somebody, that's scaffolding. So you do it as a group, literature circles, that's what literature circles is about. Somebody, my turn this week is to be the person who finds the hard words. And your part is to draw some little visual what happened. And your role is, we change roles, so we're all doing different roles and working together. So that's one. The other is reading and doing a think aloud with kids, or solving a really complex math problem together as a class, as opposed to giving the hardest thing in the world to everybody and hoping for the best that they'll be able to do it on their own. So that scaffolding can be done in those ways, with shorter examples of something. You don't expect them to read the whole novel, but you really want them to see what really rich description is in some text that they're probably not going to read the whole novel. So that's good to sort of balance that. So you want them to read full, longer text, so they understand what makes a novel. But you also, if you want to get everybody at a higher level, you may have to just pull some shorter examples. I mean, I can remember reading aloud, as a third grade teacher, as a second grade teacher, reading aloud, something to my kids. I can remember when I was in sixth grade, my sixth grade teacher reading The Borrowers, the whole series of The Borrowers. I was a terrible reader. I couldn't have read that on my own. I'm dyslexic. I didn't know that until I got to college and I read what dyslexia was. And I'm like, son of a gun. That explains a lot. So the more we read aloud to kids, the more complex ideas and have discussions about it, we're bringing everybody along. We're not just saying we can't read this independently, so you're not going to have any exposure to it. So maybe that helps. Another comment I heard was a lot of teachers might say, well, this is kind of fun to put these activities together, but miss the part about instruction. So let's talk about that. So this is sort of like an initial planning of, I'm going to teach this book, and these are the kinds of things I could do. Let's talk about how this relates to instruction, whether it be in mathematics example or science or whatever you pick. Let's just talk about it. How could this help you move a unit to a higher level, but also think about the instruction? So let's just kind of talk about that for a minute. What are your thoughts? That's Anchorage, Alaska. So I'm working in a lot of interesting places.
Well, the time of the project has to be justified in what the result is. So, sometimes in the past it would be like, make a probability game, or something, like there's sort of, and it doesn't meet the objectives of taking it that further, extending it, or...
Right. It becomes a lot of fun. A perfect example, when I was a principal, I had a fourth grade teacher who took her, it was a group that was about a school, and they went down there and they were going to look for the macroinvertebrates and draw them and come back. And they were like cartoon drawings. And she looked at what they did and she said, I guess I forgot to teach them. So it was like a total, they had a lot of fun. They went to the river, they had a lot of fun. Then they had a lesson on what makes a good scientific drawing. They looked at samples of scientific drawings. And 2 days later they went back. And when you look at the examples side by side, it's incredible. But you're right, if you're not thinking about how is this going to move us to a deeper level, it's a lot of fun to make a game. But if the time you spend making that game is pretty low level, a low level goal for a lot of time invested, it's not going to be worth it. So when are you going to really put the time into making something more complex that takes longer, as opposed to just something that takes longer and is still kind of at a low level? So that's a really good point.
Well, and then also, several of us have just this whole thing of deconstructing a task. And when you do that, then that gives you what you have to teach, because it tells you the things that the child needs to be able to know and understand and do in order to complete that task.
Right.
And that's the instruction piece.
Yep, absolutely. So this example, I have sharing muffins. So this is an example of a performance task in math. 9 friends are going to equally share some muffins. We used this in 4th grade, by the way. Each muffin is the same size. Each friend gets 1 1/3 muffins. Notice that there are no numbers given, it's all done in words. How many muffins are there altogether? Show and explain all through mathematical thinking. So if we were going to decompose that task, what do kids have to know to be successful in that task? What are some things?
We have to translate English to math.
Okay, they have to first, yeah, we're not giving them any hints of what 1 1/3 looks like even. So they have to translate words to symbolic language, which is what mathematics is, it's a symbolic language, okay? What else do they need to know? We were talking about it earlier this morning. Fractions, and like 1 1/3, remember we were talking about what's 4/3? So they have to know mixed numbers.
They have to know some of those key math terms, like how many are there all together.
Okay, so they have to know what are we going to do with this? Is this like I'm going to add, or I'm going to subtract, or I'm going to divide?
Operations.
What else? Anything else?
Well, they have to understand the concept of show and explain, because if they don't know that, you're not going to get the right answer from them that you're looking for.
Right. So they have to be able to represent it probably in some way, because you can't, can you do that in your head? Well, maybe you can, I can't do it in my head. I have to sort of draw a little diagram and do that. So they've got to actually translate that, figure out some way to organize it so they know what friend number 1 had. That's 1 1/3. Now friend number 2, what does that add? Now I'm adding 1 1/3. Now I'm adding another 1 1/3. It's fascinating how some kids approach this to figure out how to put it together, and then they have to be able to explain it and explain why. So that deconstruction of that, we actually gave this as a pre-assessment, and then we gave a similar task. So yeah, there were a lot of kids who were like, There were other ones that knew they had to set up some kind of a table probably. They started drawing things, but then they got lost, like about friend number 5. They were like, oh my God, like another 1 1/3 muffins, what do I do next? But if you look at the work, then you know what the instruction has to be. So it goes back to, and is that the only performance task in that unit? No, that was just like, can they even have a clue to get started? When we started to sort the papers, we didn't sort them. Which kids didn't even know how to get started? Which kids had a sense of, maybe they had a strategy that would start them there but fell short? Which ones kind of knew what to do, what they made calculation errors or whatever? So you're kind of starting to get a sense of, okay, what kind of teaching has to happen. And if this is the beginning of a unit where we've already done fractions without mixed numbers, maybe we're going to see that they do know how to use fractions but not mixed numbers. So that might be the focus of the teaching. So let's unpack that. That's where I might ask the question, like, what does 4/3 look like in one of those early lessons? So absolutely deconstructing and then having a couple of those. What we suggested is find out what they know in the beginning of the unit, be intentional about your teaching, having something very similar to that first one, again, now can they apply it in a different context. And by the end of the unit, maybe something even a little bit harder. So a couple of performance tasks within a unit is a good way to know if they're really making progress, and it's amazing. You can put 3 side by side, you could say 2 things. The teachers didn't teach, sometimes that was the case, or the kids didn't learn it, they only got so far. Sometimes it's a matter of how far did the teacher get with the teaching, were they able to really use the information from the data. So that's an important piece. Other observations about doing this activity, where you're just kind of starting to brainstorm, what are some levels? Was it harder to push on the 3rd level?
I was just wondering about it when you're setting up this. I started just going from 1 to 3, but then I thought, how do you set? Would you start with, the lowest level and then do an assignment for initial understanding, analysis, and opinion, or do you start initial understanding and go 1, 2, 3?
I actually started over on the hardest one.
So I'm just wondering if there was one way that was a little bit easier with people. Just take an assignment for 1 under initial understanding, and you take that assignment and go further. And I was wondering, we're way backwards.
I think
the easiest way.
you said there's multiple ways to get there. There isn't a right answer, but it's a DOK3. You have to be able to justify what your thinking is for putting these together in the way that you do. Same thing for instruction. I might decide on my menu, let's go back to the, Wants to Kill a Mockingbird, I might say, well, like I said before, it might be the first couple of days when we're reading and just talking basically about the text, that I might just be focusing on things in that first column, and I might have kids choose what they're going to do, or they might be working in groups to do different things. I'm not caring so much about who does what, but I'm caring that they all get the initial understanding. They all understand at the top, and maybe the kids who can create the quiz, the other ones can answer the questions on that quiz. That's maybe my goal for a series of 3 or 4 lessons. When I get to these, I'm having to teach them how to do those things if I want them to choose it. I say, now we're going to talk about character, because this is a lot about character analysis and interpreting the text. And you notice that at the top level, you're going to integrate what's happened in this text with another character or theme. So that's probably going to come out of a lot of class discussion, and you might choose which one you're going to focus on to create a product. And then this might be at the end of the unit, you're going to have to write a piece, a response, and you might get to choose which of those kinds of responses. So there might be some that all kids do together, there might be some that they're choosing one. I'm kind of calling the shots as the teacher, but this helps me to think about what's something on the low end, what's something on the high end, and then how am I going to integrate, those could be assignments within the unit of study. So how could you sort of deconstruct a unit? You could take the assignments you give in a unit and start to plug them in and see kind of where did my assignments take my kids? And you might say, well, I have a lot of things in the first column, I have some things in the second column, I just have one thing there. There's like one option. Maybe there could be other options for writing. And I've framed it, there's only one way you could do it. So it pushed my thinking a little bit. So I could deconstruct the whole unit and kind of back it in that way. Any other comments about doing this? We'll kind of pick up with this a little bit and we'll look at some sample tasks after lunch. Looks like it's time for lunch. Since it's 1 minute after, you get 1 extra minute. A range of the types of assignments you can give or to deconstruct an existing unit. And as you go through, say, well, where would this fall in sort of my overarching goals? But a good question to ask yourself when you're thinking about a unit, designing or redesigning a unit, what is the overall goal and expectation and the cognitive demand you're expecting by the end of the unit? And sometimes I think if we look at what we now have, we maybe aren't going as far as we could go. Then you want to look at the assessments and or the assignments you give and say, well, does that really match? Because sometimes we have these lofty expectations, but what we actually ask students to do is kind of falls a little short. And I think we sort of established that today. Sometimes we think it looks pretty good, and then when you start to take it apart, it maybe falls short. And then the last one, do the learning activities in the unit have coherence to get you there? So, you know, I've been living in Vermont for a really long time. We're famous for doing portfolios. There were schools that embedded the portfolio tasks within their units of study. And there were other schools that said, it's Thursday, we'll do a portfolio task. Guess which kind of schools had the best learning happening? It wasn't the ones who was like, oh, we're not going to do what we normally do, we're going to do something else. Or it was the ones who, as they were learning the concepts and skills, they were doing a more complex math problem solving task, or they were doing a writing piece that connected to the teaching pieces that went along with it. I mean, like, it makes sense, but sometimes when we want to make it manageable, we undo some of the good things we know about good teaching. So that idea of coherence is good to, as you're looking at lessons, how do the lessons progress in the unit? And you think about the assignment menu, well, these would be things I do early in the unit, but if I did a similar unit with another text later in the year, I'm not going to start back probably at that same starting point. I'm going to start somewhere a little bit higher as I go through. So the mapping across the year, you ought to see that continuity moving along. We know that we were talking a little bit about complex text. Within a unit, you might have a range of simple to more complex text. Maybe the first ones kids are experiencing are really clear, what you're trying to get across, and then it's more nuanced in some of the other text. So having that range as opposed to it's always predictable text. That's good. You need to have some that are predictable text, and you need to have some with it. You might have to dig a little bit for the information. But they're either developing schemas about text or schemas about problem solving. So, a couple of brave souls. Would you like to just share, I know you didn't have time to plan it all out, but share what might be an initial activity on the easier end that you mapped out, and what might you build to? So you don't have to tell us everything that's in it, but kind of give us a sense of what are some of those earlier, lower level challenging, and where would you want to get by the end of it? What's something you want to be able to do by the end? Okay, and kids, get our papers out, make a lot of noise. Okay, everybody ready to listen? Because your job as the class is to listen to the examples and kind of give feedback. Did you want to? Sure.
Yeah, so.
Tell us grade level?
Second grade.
Okay.
Telling time unit.
Okay.
Parts of a clock, hour, half hour, quarter hour. So for my lower level 1 skill, just having them draw a clock and label the parts, but there's a word bank for them to label, and we give them the times to draw. And then I moved up and had them draw and label the clock without a word bank, and they had to pick the time, an hour, a half hour, a quarter hour. And then the third level, find magazines with clocks, both analog and digital, and have them cut them out, glue them, and then write the time and tell them it was hour, half hour, quarter hour. And then we had for the concept.
So that's going from real scaffolded to, can you look at any clock?
Yeah.
It's different. You know, if it's an analog or digital, so you're trying to get them to start to generalize and tell different times.
Then for concept, for the lower one, they had them create 3 elapsed times questions with a partner, maybe at a higher, I was thinking of my class, my higher level with my lower level, and then their partner can answer the question, talking about elapsed time. Then moving up, we had them pick an important part of the day and write a paragraph about what they do at that time and why it's important. And then before they start writing, write what time they start writing and write what time they stop writing and tell how long it actually took to write that paragraph. Because I found when I did my pre-assessment for time, they all thought it took a minute to paint a picture. So,
Some pictures probably take
yeah.
Not the good ones.
And then for the third level for concept, have them have stopwatches and go around the school and make predictions of how long things would take in the school and work with a partner and then actually time those things and then collect the data and maybe even go further and have them graph the data and go on like that. And then for problem solving, for the lower level, draw a clock and show 3 different clocks, hour, half hour, and quarter hour, and explain why the hands are where they are and how they know that that's the time. And then maybe for the second level, have them do like a home clock discovery where they have to go around their house and find out what clocks they have, draw them, tell what time they are, and why is that clock in that place. You know, if there's a digital clock on the stove, or why are those clocks where they are. And then for the top level, take a digital clock, which is the easy one, transferring it, making it into an analog clock.
Digital clocks are like sneakers with Velcro. You have to learn how to tie your shoes, you have to learn how to really tell time.
And then show 3 different times, and then pick which one they prefer, which kind of clock, and then explain in detail why they prefer that. So that was the whole.
Okay, so you see a whole variety of activities there. Any comments, any thoughts about?
Any other activities?
Just keep teaching them clockwise and counterclockwise. Because we tried to do rotations and the digital clocks, the kids don't know.
I didn't even thought about that. Yeah, that would be